Hey, this is Mrs. Rodriguez with another lesson video. Today we're going to look at how to solve one-step equations. So first of all, what are equations? Well, equations are different than expressions because equations actually have an equal sign, okay? So that means we're not just simplifying like we were simplifying with expressions. We're actually now going to solve and find the answer for the variable. So if there's an x in there, we're going to actually solve and find what x equals, okay? Also, an equation's different in the sense that we have to keep it balanced, which we're going to go more into in just a minute. So here are two examples. One's an expression, one's an equation. Now, if we look at the expression, you'll see that there's no equal sign. All we can really do is simplify by doing the distributive property. So, I could simplify and I end up with 2x plus 2, but there's no answer. There's nothing to solve. We don't know what x is, okay? That's an expression. You can only simplify. Now, equations, on the other hand, this is where the equal sign comes into play because that means we can actually solve this and get an answer. So we would still use the distributive property to simplify, but the whole goal of solving an equation is to find out what does x equal, okay? Now, what do I mean by balancing an equation? It's very important when we're working on equations that we make sure that they're balanced. All right, as you can see, think of this as like a teeter-totter and the equal sign where your equation balances. On the left, you'll notice that 2 plus 3 is 5, and on the right, 10 minus 5 is also 5, so it balances. But if I were to add, subtract, multiply, do something like that to one side of the equation, all of a sudden it's no longer in balance. In this example, the left-hand side is still 5, but now the right-hand side, because I added a 4, becomes a 9. And 5 does not equal 9. Doesn't work, doesn't make sense. So this is the importance of balancing equations. We're going to be doing different things to equations. We're going to be adding, subtracting, multiplying, and dividing things. And that's okay. We just need to remember that if you're going to do it to one side, you need to do it also to the other side. Because then we have 2 plus 3 plus 4, which is 9, and 9 does equal 9. So as long as whatever you're doing to the equation, you do to both sides of the equal sign, you're good, because it will keep the equation balanced. Okay, so how are we going to solve equations? Well, we're going to use something called the RISC method, okay? RISC. R stands for the river, I for inverse, which means opposite, and S is solve, C is check. Okay, this is the method we're going to be using. Now, inverse means opposite. And you might be thinking, opposite what? Well, it's actually going to be opposite or inverse operation. And our operations, our math operations, are addition, subtraction, multiplication, and division. So we're looking at what's the opposite of these operations. Well, for addition, the opposite would be subtraction. For subtraction, the opposite would be addition. For multiplication, the opposite would be division. And for division, the opposite would be multiplication. So we're going to do the river, and I'll show you what that is in just a minute. And then we're going to do the opposite operation. So if you see an addition sign, you're going to do the opposite and subtract. If you see a subtraction sign, you're going to do the opposite and add. If you see multiplication, you'll do the opposite and divide. And if you see division, you'll do the opposite and multiply. Okay? And always, always, always keep in mind, we got to keep the equation balanced. Okay? So let's take a look at our first example. Here we have x minus 27 equals 6. So remember, we're going to do the RISC method. So we start off with the river. Now, the river, there's different ways you can do it. Some people actually like drawing kind of a river shape. Another thing you could do is just use lines. I like to use 2 lines. And what the river is we're just setting up some lines around or on the equal sign so we know where the 2 sides are that we have to keep balanced in the equation. Okay? It's to help us know, okay, whatever we do on this side, we have to do on the other side of the river. All right? And so it's like a visual reminder we have to keep our equation balanced. If you see something going on the left-hand side of the river, then you know you should also be seeing it on the right-hand side of the river. So that's what the river's for. Okay, now second step, inverse operation. So we have x minus 27 equals 6. The whole goal for solving equations is to find out what the variable equals. So we want to get x by itself. If we want x by itself, that 27 is a problem, okay? So I'm going to be looking at that going, all right, what operation is it? It's x minus 27, okay? I'm supposed to do the inverse or opposite. The opposite of subtraction is addition, so that means I'm going to add 27 to both sides. Okay, I'm going to add 27 to both sides. And we do the inverse because when you do the inverse operation, it cancels the number out. So now we have 27 positive, right? And we have minus 27. So 27 subtract 27 is 0. They cancel out. Or positive 27 plus negative 27 would be 0. It cancels out. And lo and behold, we get x all by itself. I like using the double lines for the river because I like putting the equal sign in there as I work along showing my steps. But like I said, it doesn't really matter what kind of river you use. Now we have to do the right-hand side. We have 6 plus 27, and 6 plus 27 is 33. So that's how you solve. And we get an answer of x equals 33. Perfect. Now the last step in the risk is you can actually check to see if you got the correct answer. And the way you would do that is you would start back with the original equation, x minus 27 equals 6. Okay, now we're saying that x equals 33. I can go ahead and plug that in for x and see if it works. So if x is supposed to be 33, then 33 minus 27 should equal 6. If it does, great. If it doesn't, we know something happened, right? We did something wrong. And it turns out 33 minus 27 is 6. So yes, it worked. And it's good. Now, if you were to do, let's say we got x is 35. Well, when we go to check it and we plug in 35, it would be 35 minus 27. And 35 minus 27 is not 6, it's actually 8. And then we would know, okay, something's wrong because the answer didn't come out to be 6. All right, so that's how checking works. You plug it in and you see, do you get the answer you're supposed to get when you plug in your answer for x? All right, let's try another one. So that was an example of subtraction and doing the inverse addition. If it was x plus 27, we would do the inverse and we would have been subtracting 27 from both sides. So that's an example of addition and subtraction. Now we have this one. This is negative 4x equals 72. Now, negative 4x means we have negative x 4 times. So that means this is actually multiplication. So anytime you see a number next to a variable, it stands for multiplication. All right, the river. Step number 1, I'll draw a different river so you can see. You can have any kind of river you want. Step 2, do the inverse. Well, if this is multiplication, the inverse or opposite of multiplication would be division. So that means I'm going to divide both sides by negative 4. And remember, I have to do it on both sides to keep the equation balanced. Whatever you see on one side of the river, you have to also see on the other side to keep the equation balanced. Now, -4 divided by -4 is like any other number divided by itself. It equals 1. And 1 times x is just x. So these cancel out, and we just get x equals 72 divided by -4. Okay, and actually when you're adding and subtracting, they cancel out because it ends up equaling 0, right? The number ends up adding or subtracting to 0. When you're multiplying and dividing, the number ends up multiplying and dividing by itself, so it'll always equal 1. And then 1 times x is just x, or x divided by 1 is just x. So trust me, no matter if you're adding, subtracting, multiplying, or dividing, whatever the inverse is, the number will cancel out. All right, so now I have 72 divided by -4. 72 is positive, -4 is negative. So a positive divided by a negative, they're different signs, so my answer is going to be negative. And then 72 divided by 4 is 18. So my answer is going to be x equals -18. Once again, we can check to see if we did this correctly by starting with the original equation. -4 times x equals 72. We're saying that x equals -18. And now I'm going to plug in -18 for x and see, does it work? Will I get positive 72? And if you check it, 4 times 18 does equal 72, and we have two negatives. They both have the same sign, right? They're both negative, so that means our answer is going to be positive. So yes, it equals positive 72. All right, so that's an example of a problem with multiplication, and you're doing the inverse of division. So that leaves the last math operation to look at, which is division. Here we go. In this case, we have -14 equals x divided by -9. All right, so step 1, the river. I'm going to go back to my 2 bars. Okay, step 2, inverse operation. So remember, we want x by itself, so I'm looking at the x, and it's being divided by -9. So the opposite of division is multiplication. So that means I'm going to multiply both sides by -9. Okay, so -9 times -1/9 equals 1, and then 1 times x is just x. Okay, so these do cancel out. We get x by itself, and then we look at the other side and we have a negative times the negative. So once again, both have the same sign, so my answer is going to be positive. And then I do 9 times 14, which is 126. So my answer is going to be x equals 126. To check it, let me go ahead and kind of draw a little line here. To check it, we start with the original equation. We're saying that x is 126. We're going to plug that in for x, and we're going to see, does 126 divided by -9 equal -14? And yes, it does. All right, so that's how you solve one-step equations. Remember, they're called one-step equations because there's one step. We're only doing the inverse operation once, okay? We'll be looking at two-step and multi-step equations and how to solve them in later videos. So remember, the river, inverse, solve, check. The risk method, don't forget, risk method. River, inverse, solve, check, and make sure you keep that equation balanced by doing the same thing on both sides of your river. Okay, and like always, if you need additional help or have any questions, feel free to make an appointment with me for office hours. Hope you have a great day. Bye.